In terms of fuel control, okay, I've got the airplane data interfaces. I've got the specifics on how much fuel I need to burn because this is a 700 aircraft, or the thrust limitations, etc. I've got information about all the sensors that enable fuel control, the EEC, which is the brain of the engine fuel and its control, and the hydromechanical unit, which is the line replaceable unit, which does the fuel control. All right. So if you can imagine, this is the engine, the EEC, the brain. This is the hydromechanical unit, and they are in close tandem because the HMU is what actually sends the metered fuel to the engine. After it gets information from the fire switch. So if the fire switch is on, then the engine can't be started or will shut down if it was on. So that's important information. Engine air control, HP valve, if it's opened or closed, or the EEC will command it to open or close depending on what phase of the engine run we are at. Start lever details, or the engine, the EEC controls the start of the engine. And the EEC controls the thrust reverser after landing, when it's operating, how the timing of it, how long it should be open for, and how long after resetting the thrust levers everything should close up again. The EEC takes information from the oil, especially the pressure and quantity and other things. Also, we need information from the AC transfer bus and the AC standby bus. We'll talk about that in a minute. The EEC then, with information from the identification plug, from the sensors, the fuel flow transmitter, the engine strut, and the EEC alternator, then enables the two DEUs to display the information and also helps to control the FMS. What is the FMS? FMS is I'm using the navigational data I have to fly from A to B as economically as possible. And the EEC needs information from the ADIRUs to do that, and from the FCCs for the autopilot to be able to do this FMS thing, to do a flight from A to B as economically as possible. As we saw before, all the information also goes to the flight data acquisition unit and eventually to the FDR. So for engine control, I have an EEC alternator. Okay, this is again bolted to the accessory gearbox on the front phase of the gearbox, and as long as the engine turns, the EEC has power. The EEC channel A and channel B have electrical power for as long as the engine is running. The hydromechanical unit, this is its location, and then we have the PT25 sensor. So this is pressure and temperature sensor at station 25. Other components are the ID plug, the T12 sensor. The T12 sensor is on the inlet cowl, right at the front of the engine, and the ID plug as well is connected to the engine. So the EEC is responsible for starting, shutdown, and ignition control. It's responsible for engine thrust control. It's responsible for the reverser thrust control. It's responsible for the engine core control, the actual air going through it, VSVs, VBVs, how they're operated and everything. It's responsible for the high pressure turbine active clearance control and the low pressure turbine active clearance control. It also gives indications in the cockpit. It's an expensive bit of kit. As we know, the FEDEC is the brain of the engine. Very reliable though, in 2 channels. Identical channels, so it invariably doesn't go wrong. The ID plug, as we said, it attaches to the engine. Although it's connected to the EEC, if you're changing the EEC, you take the EEC away. The ID plug is attached with a lanyard onto the engine. You then put the new EEC in and attach the existing ID plug onto the new EEC. Okay, because this ID plug will supply configuration data to the EEC. When we say configuration data, what do we mean? What type of engine is it? 7B, for example. What the N1 trim is, what the thrust rating is, what the engine condition monitoring is, the engine combustor configuration, etc., etc. So it's a fairly important thing, and it stays with the engine because the engine is what determines the configuration and what the EEC has to work to. So on the right hand side of the fan case, and connects to the P11 connector. All right. This is as complicated as we're going to go. Just thought I'd put it in just to show you how the EEC is always powered. So you can see the EEC, and this is the power bit here, channel A and channel B. So we'll go with the easy bit. If the engine is running, this EEC alternator, okay, that's connected to the forward face of the transfer gearbox is rotating. And as this is a rotating sort of transformer coil, we get 115 volt AC power to channel A and channel B of the EEC all the time. Okay, so as long as the engine is running, the EEC is working. But well, what if the aircraft's on the bay? Then we have some logics. For example, if we're going to start the engine, or if we put the start switch to the ground position, okay, or put the start switch to the continuous ignition, for example, or the CDU in a specific maintenance position, we could actually make this switch. This makes this switch, gives the alternate power relay, okay, and enables, once this closes, alternate power to channel B, alternate power to channel A to connect power 115 volts to that one and 115 volts to that one. Supply power when the engine is not rotating. All right, so we can have engine rotating, the EEC alternator is providing power. Engine is not rotating, the aircraft power is providing power to the EEC if we force something on. So there's no power on the EEC. If you're sitting there on the bay, the EEC will not be powered because there's no need for it to be powered. But if you want to put power on it, one of these things, okay, we'll make this relay and we'll make this relay and we'll close these and provide aircraft ground power for channel A and channel B. So EEC has two channels, A and B, as we saw. It's duplicated for redundancy, and they are always talking to each other via ARINC 429 through this cross-communication data link. So the data is duplicated. Whatever happens to channel A, channel B will be able to fully take over and fly the aircraft. Okay, we did say if some of the components of a channel are lost, then the EEC can revert to an alternate status. Okay, saying that only one channel is now working. Therefore, you have to convert the other engine to an alternate status by just pressing the button, basically, lifting the cover and pressing the button so that they're both in the same status. One channel is perfectly capable of operating the engine. We also have dispatch levels for the EEC when these lights come on. Okay, so the engine control light is a no-go. The engine reversers, we said they're one of these, they're transient lights. They'll come on, or they can come on the ground when the reverser has a problem, or they can come on the ground when the reverser is in the stow condition. It's in process of being stowed. And the alternate lights come on when some parameters of the EEC have been lost, and we are reverting now to the alternate function of it. In terms of faults, we have short time faults, long time faults, and economic faults. So short time faults can be deferred and is based on 150 flight hours. If a short time fault is detected, the number of remaining flight hours for deferral must be calculated. So, for example, if you're doing a bite check, it's a scheduled thing every 70 flight hours, for example, then you have a new short time fault can be deferred for 80 flight hours because at 70 flight hours plus 80 flight hours is the 150 flight hour limit. There's no flight compartment indications for long time faults. A long time fault can be deferred and is based on 500 flight hours, and you have to do the same calculations. There's also no flight compartment indications for the economic faults. The economic faults occur when the EEC finds a fault condition that does not have a set deferral time and should be corrected by the operator when convenient. How can we have a fault and let it fly? Well, there are faults that are allowable to fly. They'll just make the engine more inefficient. And if your operation can live with that, then so be it. The CEC can be tested on the CDU. Okay, and you can see, for example, we can fish out recent faults on it, fault history, previous faults, the ident configuration. We can perform specific ground tests. We can look at input monitoring parameters. All these are selectable sub-menus of this menu where you can perform different tests.